I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
What if artificial intelligence could not only talk like us, but think like a scientist? That's the next frontier of AI, where machines move beyond chatting and start reasoning. Welcome to the era of deep scientific LLMs, large language models designed to solve complex problems in math, physics, biology, and beyond. Today's systems like ChatGPT, Gemini, and Claude have mastered natural language, creativity, and even coding. But when it comes to real science, multi-step reasoning, abstract math, or symbolic logic, even the best of them still stumble. That's changing fast. Most current language models work by predicting the next word, not reasoning through a problem. They recognize patterns from vast data, but don't truly understand equations or proofs. Ask them to solve a complex calculus problem or derive a physics formula, and they often produce elegant-sounding but wrong answers. It's like memorizing the steps of a recipe without ever tasting the food. They lack the structured, logical thought processes that scientists use, the ability to test assumptions, calculate step by step, or connect distant concepts across disciplines. That's the limitation researchers are now determined to overcome. A new generation of AI systems is emerging, models that reason. They're trained not just to respond, but to think through problems logically, one step at a time. Using what's called chain-of-thought prompting, these systems break complex tasks into smaller, checkable steps, almost like showing their work in a math exam. Then comes self-correction, where the model reviews its own logic, flags inconsistencies, and revises before giving an answer. This think, check, and explain method dramatically reduces hallucinations and improves accuracy. Some models even blend neural networks with symbolic reasoning engines, tools that follow strict mathematical logic. Imagine combining the intuition of a human researcher with the precision of a computer algebra system like Mathematica. That's hybrid neuro-symbolic AI, a fusion that lets machines solve equations, prove theorems, and explain why their answers make sense. The next leap comes when AI begins to work autonomously. Picture asking about the latest experiment in quantum superconductivity. Instead of relying on old data, the AI searches new papers, reads scientific journals, and extracts key insights all in real time. These systems act like digital research assistants, browsing RxIV, verifying claims, citing sources, and synthesizing results from multiple disciplines. They can cross-check astrophysics data, compare genetic studies, or summarize chemistry breakthroughs instantly. This capability transforms large language models from static databases into active researchers. And the implications are enormous. In classrooms, next-generation AIs are becoming personalized tutors, explaining advanced topics in simple and adaptive ways. In research labs, they accelerate discovery by scanning thousands of papers, generating hypotheses, and even suggesting experiments. Engineers use them to optimize complex systems, from chip design to aerospace propulsion, while pharmaceutical teams explore new molecules and drug interactions. These models can compress months of scientific trial and error into hours, a revolution in productivity and discovery. And make no mistake, this is a global race. OpenAI's confidential project Strawberry aims to create reasoning-capable models that can plan, calculate, and hypothesize like scientists. Google DeepMind's AlphaGeometry merges logic with deep learning to solve geometry problems at Olympiad levels. Anthropic's constitutional AI is teaching models to reason ethically and logically, ensuring consistency and trust. Meanwhile, China is investing heavily in domain-specific models across physics, aerospace, and quantum computing as part of its 2030 AI leadership strategy. From Silicon Valley to Beijing, the race is on to build AI that can truly think. Of course, challenges remain. Hallucinations, when AIs generate confident but incorrect statements, are still common. Accuracy, bias, and scientific validity are constant concerns, especially when models summarize or interpret real research. Ethical questions also arise. Who owns an AI-generated hypothesis, and how do we credit discoveries made by machines? Developers are responding with new safeguards like adversarial testing and human-in-the-loop validation to make sure AI remains both reliable and accountable. But one thing is clear. The next wave of large language models won't just answer questions. They'll ask them, test them, and maybe even discover new laws of nature. We're watching the birth of reasoning machines, a quantum leap not only in technology, but in the very nature of intelligence itself. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.